So now let's do the integration. So for the first one, integral of x squared divided by x minus 1 ds. So we need to use long division to split this integral. So use your long division. So you are dividing x squared by s minus 1. So put s minus 1 outside. Complete this by putting 0. 0s plus 0. So you can easily understand. If the power of your polynomial is 2, the next power will be 1. So because it's missing, we put 0 there. Then the constants, that's quadratic complete. So this x squared divided by x, meaning the x squared here divided by the first letter here. S will cancel out, so that is x. So that's long division. That means x in x squared, that is s. So now this s will open this bracket. So get the pattern. Again, x squared, this x squared divided by s. So this will cancel, it remain s. That's the one you write there. So now that x will expand this bracket. Now s times x, that is x squared. Again, x times minus 1, that is minus x. So now subtract. If you subtract, you have x squared minus x squared, 0. 0x, then minus times minus plus. So 0s plus 1s. So that is x. So plus 0. Bring this 0 down. Again, this x divided by this x. So that is 1. So x in s, 1. That's plus 1. So 1 times x again. X. That is 1 times x, x. Again, 1 times minus 1, minus 1. So subtract again. So minus times minus, minus x minus x, 0. Minus times minus plus. So 0 plus 1, that is 1. So that is using long division. So what does a long division means? It means you say quotient we have 1 s plus 1, as in this quotient, plus remainder over divisor, like this. So you write your quotients, this is it, then this remainder 1, write it up, over this your divisor, s minus 1. Do you get that now? So let me show that because of another question. Quotients here is equals to, we represent quotient as q. We represent quotient as q. is equals to s plus 1. This one is cotangent. Divisor, we represent divisor as d, that is x minus 1. This is the divisor. Then remainder, we represent the remainder as r, so which is 1. So this is remainder. So we now have polynomial p is equals to quotient times divisor plus remainder. So if you divide everything here by divisor, so you have polynomial divide everything by divisor. So we now have divisor cancel out. That means polynomial divided by divisor is equals to quotient plus remainder divided by divisor. So this is what you need here. So your polynomial is the s square here. So if you use this now, so that means polynomial divided by divisor equals quotient plus remainder over divisor. So that means polynomial is s square. So s square divided by s minus 1, divisor is s minus 1, to be equals to quotient. Our quotient is s plus 1 plus remainder is 1 over divisor. So that means if you find the LCM of all this, you should get this back. That is the meaning. So that's the meaning of what you have here. So our integral now will change. Our integral will now becomes, so let me now clear this. So this our question now becomes integral of this s square over s minus 1 ds is now equals to this expression here. Remember, we have shown that this is this. If you put over 1 here, over 1, you will see that LCM is s minus 1. So we now have s minus 1, that is 1 in the LCM, plus s minus 1 plus 1. So expand the up one, s square minus s plus s minus 1 plus 1 over s minus 1. Do you see everything here cancel? It will remain s square over s minus 1. So that is how we get that. A minute we go back to down. So that means our equation now our question now becomes s plus 1 plus 1 over x minus 1, that is quotient plus 1 over remainder. So we have shown that this is equals to this using that long division. So this will now be integral of this ds. So that's it now. So this will become integral of s square over s minus 1 ds is equal to integral of s ds plus integral of 1 ds plus integral of 1 over s minus 1 ds. So if you have turned it to this, you have used long division to change it, everything is now simple. So integral of s square over s minus 1 ds now becomes, so integral of s, this is power 1, that becomes s raised to power 1 plus 1 divided by 1 plus 1 plus integral of 1 constant, that will be x, plus integral of this. So the technique here is that if you differentiate what you have here and you get what you have here, answer is log of denominator plus c. That is integral of 1 over s. For example, if I differentiate x, I will get 1. So anytime you differentiate this denominator and you get the numerator, answer is ln of denominator plus c, like that. So sometimes you now see us putting this modulus here, meaning that s cannot be negative there. So plus, so and remember how we did this. This is definition of integration. Integral of s raised to power n ds is s raised to power n plus 1 divided by n plus 1 plus c, constant of integration. This is formula for integration. So you add 1 to the power divided by that power again. So the power here is 1. So we have 1 plus 1 divided by 1 plus 1. So, so plus ln s minus 1 plus c. So that is, if you differentiate this, you get 1, it will be equal to the up 1. So answer will now be ln of this down 1. Then you add your constant of integration. So this is it. So this will becomes integral of s square over s minus 1 ds is equals to s square over 2. So that is 1 plus 1, 2, divided by 1 plus 1, 2, plus x plus ln s minus 1, so plus c. So that is our final answer. So that means integral of this, so you have to jot all this, there's no space there. Finally, it means integral of s square divided by s minus 1 ds is equals to s square over 2 plus x plus ln s minus 1 plus c. So this is the answer. Now the second question. Second question. Integral of 1 over s square plus 1 over s cube minus 1 over s raised to power 4 ds. Change everything to its index form. So this is integral of s raised to power minus 2. So because that is 1 over, so plus s raised to power minus 3 minus s raised to power minus 4 ds. So all this over, will change it to s raised to power minus. So using the definition of integration, so we are adding 1 to the power divided by the power again plus s raised to power minus 3 plus 1 over minus 3 plus 1 minus x raised to power minus 4 plus 1 minus 4 plus 1 plus c. So this will becomes x raised to power minus 1 over minus 1 plus x raised to power minus 2 over minus 2 minus x raised to power minus 3 over minus 3 plus c. So this is x minus that this minus we come minus x raised to power minus 3. So plus times minus minus s raised to power minus 2 minus times minus plus s raised to power minus 3 plus c. So turn everything back to over. So that means integral of this is equals to minus 1 over x. So turn this back to 1 over. Then this will go back to 1 over x squared. So that will be minus 1 over 2x squared. Then plus 1 over 3x cubed. As in this one too will turn to 1 over. So if you have 1 over 2 times 1 over x squared, that's what we did there. So it will be 1 over 2x squared. The same thing here, 1 over 3 times 1 over x cubed. So that is 1 over 3x squared, x cubed. So like that. This is also 1 over 3 times 1 over x cubed. So that is 1 over 3x cubed. So like that. So plus c, constant of integration. So that is the final answer. So we have solved the question.